Good morning, students. Tomorrow morning, a wonderful thing is happening in the pre-dawn hours around 4:15 in the morning for us. It is going to be a total lunar eclipse. What is a lunar eclipse?
And Mr. Fields, why can't we do this sometime during the day? I'm going to be sleeping at 4:15 in the morning.
Well, this is why. The total lunar eclipse has to happen at nighttime, and the total solar eclipse has to happen during the day. Let's look at the reasons why. For a solar eclipse, we're going to have this flashlight as the sun, and you're there on the Earth, and we're going to have the moon pass in front of the Earth, and it's going to block out the sun just temporarily, and that is a solar eclipse. Now, on the other hand, if we're going to have a lunar eclipse, the sun needs to be on the other side of the Earth. So if we have, this is our Earth right here. Let's see, can you see that? Okay, so here's our Earth, and here's our moon. Now, the moon needs to have a shadow of the Earth cast on it. For a lunar eclipse, you have the sun on this side, here's the Earth, and here is the shadow of the Earth. The moon, as it's going through its phases, at this point here is starting to come into the full moon phase, all right? And as the Earth is turning, sometimes we're seeing it, sometimes we're not. The Earth is turning, this side is nighttime, this side is daytime. When the moon passes into the shadow of the Earth, it's going to pass in so people on the moon, or on the nighttime side, are able to see the eclipse of the moon. When we're looking at a solar eclipse, the moon is passing and casting its shadow on the Earth, and that is only going to cast a shadow on certain parts of the Earth because the moon is so much smaller. But the moon casting its shadow happens during the daytime. It's happening during the nighttime for the people on this side of the world, but they can't see it, so they'll have to hope that it's still happening when they're on the daytime side. But it doesn't happen for very long. So this is a solar eclipse, and this is a lunar eclipse. Now, when we have a lunar eclipse, the shadow of the Earth actually changes the color of the moon, because once it passes into the shadow, completely in the shadow, the only light that's hitting the moon is the light that's filtered through the atmosphere of the Earth, where some of those light waves are absorbed, some of them are slowed down a bit, and the only light that's coming through is the red end of the spectrum. Now, on the visible light spectrum, we have all of these different colors, and these colors have different wavelengths. We have the purple end of the spectrum, which has
the shortest wavelength
and the most energy, and then the slowest, longest end of the spectrum, the red end of the spectrum, which has the longest wavelengths. These waves are long and slow. This is what we see when there is a beautiful sunrise or sunset, or after a rain when there's a lot of water particles in the air that the light is bouncing off of and getting absorbed by, or as we've seen with our wildfires, we see that the light in the sky is slowed down by all the smoke particles. I hope you have a chance to see the super full moon eclipse tomorrow morning, but you really should be sleeping, so maybe I didn't tell you that. Have a great day, guys.